Day 2, lesson part 3, compound inequalities. So there's two kinds. There's the ones that we call and or. So let me explain those to you. Let's start with and. So an and inequality would be like this. Let's just say you're going to go buy a foot-long Subway sandwich, right? Well, there should be an actual measured amount that a foot-long should be. But we know that we never get exactly a foot-long sandwich. So at Subway, the foot-long sandwich can be greater than 11, but less than 13 inches. So greater than 11, but less than 13. So it would look like this. 11 would be an open circle going this way, but this bottom one would be an open circle at 13 going this way. And instead of having arrows, they combine. So you have this range of sizes. So you can have an 11.5-inch sandwich, a 12-inch sandwich, a 12.5-inch sandwich. So this is what an and looks like. 2 points, and in between them are your answers, okay? Now, an or would be something like this. Let's say you're going to throw a party. Now you can have a small party with 10 or less people, keep it small, or you can have a big party with 50 or more people and have everyone at the school come. But if you had a party it's in between, it doesn't really work because then people are going to ask, well, why were they invited? Why wasn't I invited? So in this case, you can have a party that's less than or equal to 10. So this will be a closed circle. So like a small hangout. Or you can have a big party where everybody, X is greater than or equal to 50. Your guest list is greater than or equal to 50 people. All right. And then this is what an or looks like. There's two different answers going in two different directions, and there is a gap where there is no answer. Okay. So these are the two kinds of compound inequalities that we have when you graph. Now, when they look like problems, they can look like this. Now, when you have an and problem like this, you're solving for y in the middle. Now, there's two ways you can do this. You can block this out and say, okay, solve for y right here. Just get rid of the 2 and tell me what y is over here. Then you would do this problem. So you basically create two problems where you have to solve for y. But there's another way to do this. If you want to solve for y, the y needs to be by itself. So that means in the middle, right here, you want this to just be a y. Now, how can you make that just be a y by itself? Well, get rid of the number in the middle, which is a 2, using inverse operations. What's the opposite of adding 2? Subtracting 2. But where do you subtract it from? You subtract both sides. So you're going to subtract 2 from both sides. All right, so on this side, you got minus 4, minus 2. They're the same sign, so it gets bigger. You get negative 6. Negative 10 minus 2, you get negative 12. So your answer would look something like this, where y is greater than negative 6, but less than negative 2. And if you graph this on a number line, you would have negative 6, right? Negative 6 is greater than, so you go negative 12. You would have it like in the middle kind of range. So yeah, something like that. Okay, you would then graph it on the number line, and the numbers would be over here on this side. Okay, now for this bottom one, when you see an or, they're split up. You just solve them both separately. So here I move the 5, minus 5 from both sides. I get negative m and minus 1. Okay, so over here I will divide by 7. So I get 5. Now, they look like they're done, but this one isn't, because you can have a negative with the m. So to get rid of this negative sign, we're going to divide by negative 1. You divide by negative 1, the signs change. They both become positive. And because of that, this sign flips. So your answers actually look like this. M is greater than 1 and M is greater than 5. And you would graph both of those on a number line, right? So you'd have a number line, 1, you'd have 5, your circles and your arrows to put them on there. Now you can have sometimes, I think in this case, both arrows go in the same direction, which is fine. That happens sometimes. Because you flip the sign, they both say greater, both arrows would go to the right. So you have what looks like just going this way. All right, next. Sorry, gotta switch this. All right, now identifying graphs. Let's talk about these graphs. How do you write inequalities from the graphs? Well, you have to write two of them. So in this case right here, you would write the inequalities x is what? Greater than or less than? Well, it's going left, so less than -1. Do you put a line underneath it? No, because it's an open circle. This one, however, x is greater than, and because it's filled in, equal to 2. And you have these two answers. Now, because you have the two answers going in two different directions, this would be an or. That would be an or. Either your answer x is less than -1 or x is greater than 2 or equal to 2. Okay, same thing here. We're going to write our two answers. So we have here, I think that's -3. So yeah, so here in this case, x is greater than or equal to -3 because it's going to the right. In this case, x is less than or equal to 2. Now, this is an and the reason you know it's an and is because the answers are in the middle. So another way to write this is like this, guys. This is another way you're going to see the answers written. X is in between the two numbers. So x is greater than -3, but less than 2. And this is actually the most common way you'll see it written. These are not wrong, but you're going to see the answers more written this way for those kinds of problems. And yeah, guys, those are compound inequalities, two answers on the same graph.